Hello friends, I am Balasaheb Nivdunge, Assistant Teacher of Sri Dhokeshwar, Vidyalaya Takri Dhokeshwar. First welcome in the online test of Ahmednagar Jilla Maratha Vidya Prasarak Samaj, Ahmednagar. In 10th standard mathematics paper, first, third chapter, arithmetic progression. We know that in previous lecture we have already learned what is meant by sequence and definition of arithmetic progression. We know that sequence is a collection of numbers arranged in a definite order according to some definite rule. Also, we have studied terms of sequence: first term, second term, third term, denoted by T1, T2, T3, T4 and so on. Also, definition of arithmetic progression. If in a sequence difference between any two consecutive terms, that is Tn plus 1 minus Tn, is constant, then that sequence is called an arithmetic progression. Also, that difference is called common difference and it is denoted by D. Now, today we are going to study some problems depends upon sequence and arithmetic progression. That is the practice set 3.1. Now, first question in practice set 3.1 is: which of the following sequences are arithmetic progression? If they are arithmetic progression, find the common difference. So here we have to given some sequences and we have to check which are them are arithmetic progression, and if out of them some sequences are arithmetic progression, then find the common difference. Now let us study first sequence 2, 4, 6, 8. Solution. Here the first term T1 is equal to 2, second term T2 is equal to 4, third term T3 is equal to 6, fourth term T4 is equal to 8 and so on. Therefore, difference between first two terms T2 minus T1 is equal to 4 minus 2 is equal to 2. T3 minus T2 is equal to 6 minus 4 is equal to also 2. Difference between fourth and third term, that is T4 minus T3 is equal to 8 minus 6 is equal to 2. So see here, from this difference between any two consecutive terms, that is a Tn plus 1 minus Tn, is equal to 2. Therefore, D is equal to 2, which is a constant. So, according to the definition of arithmetic progression, the given sequence is an arithmetic progression. Similarly, and the common difference is D is equal to 2. Similarly, consider the second example. Sequence is 2, 5 upon a 2, 3, 7 upon a 2 and so on. First of all, see, first term T1 is equal to 2, T2 is equal to 5 upon a 2, T3 is equal to 3 and T4 is equal to 7 upon a 2. Now taking difference between first two terms, that is T2 minus T1, therefore T2 minus T1 is equal to 5 upon a 2 minus 2. Now taking LCM is 2, so multiply by 2 here to the second term, At numerator and denominator we have 5 upon 2 minus 4 upon 2, which is equal to 5 minus 4 upon 2, which is equal to 1 upon 2. Similarly, difference between T3 and T2. So T3 is 3 minus T2 is 5 upon 2. Again taking LCM 2. So multiply here by 2. We have 3 into 2, 6. So 6 upon 2 minus 5 upon 2 is equal to 6 minus 5 upon 2, which is equal to 1 half. Similarly, T4 minus T3, 7 upon 2 minus 3. Again taking LCM is 2. So multiply by 2 to the 3. We have 7 upon 2 minus 6 upon 2, which is equal to 7 minus 6 upon 2, which is equal to 1 upon 2. So from this, the difference between any two conjugative terms, that is Tn plus 1 minus Tn, is equal to half. So according to the definition, D is equal to 1 half, which is constant. So according to the definition of arithmetic progression, the given sequence is an arithmetic progression and the common difference D is equal to 1 half. Third example, minus 10, minus 6, minus 2, 2 and so on. Solution. Here the first term T1 is equal to minus 10, T2 is equal to minus 6, T3 is equal to minus 2 and T4 is equal to 2 and so on. Now taking difference between first two term, that is T2 minus T1, T2 minus T1. We have T2 minus T1 is equal to minus 6 minus minus 10, means minus 6 plus 10, which is equal to plus 4. Then T3 minus T2 is equal to T3 is minus 2 minus sign as it is, T2 is minus 6. So minus 2 minus minus 6, minus 2 plus 6. So addition of positive term and negative term. So difference is 6 minus 2 is equal to 4 and give the sign of larger term, that is positive. So plus 4. Similarly, T4 minus T3 is equal to 2 minus minus 2, which is equal to 2 plus 2 is equal to 4. So observe that difference between any two conjugative term is constant and that is equal to 4. So from this, difference between any two conjugative terms, that is Tn plus 1 minus Tn is equal to 4. Therefore D is equal to 4, which is a constant. So by the definition of arithmetic progression, the given sequence is an arithmetic progression and the common difference D is equal to 4. So in this way, if we have to given a sequence, then we can check whether the given sequence is an arithmetic progression or not. Now second question of the practice set 3.1, write an arithmetic progression whose first term is A and common difference is D in each of the following. First A is equal to 10, D is equal to 5, second A is equal to minus 3, D is equal to 0, third A is equal to minus 7, D is equal to half. Now consider one by one. First A is equal to 10, D is equal to 5. Solution. A is equal to T1 is equal to 10. So find the second term. T2 is equal to T1 plus D by adding the common difference d in the previous term. So we have 10 plus 5 which is equal to 15. Then T3 is equal to T2 plus D, again adding common difference to the previous term. So 15 plus 5 which is equal to 20. Now find out T4. T4 is equal to T3 plus D, 20 plus 5 which is equal to 25. Therefore answer is 10, 15, 20, 25 is the required arithmetic progression. So see here, if we have to given first term A and common difference D, we can find out the whole arithmetic progression. Second example, A is equal to minus 3, D is equal to 0. Solution, here A is equal to T1 is equal to minus 3, that is the first term. A is equal to T1 is equal to minus 3. Now find out second term T2 by adding the common difference D. So T2 is equal to T1 plus D. So adding common difference D in the previous term T1. So minus 3 plus 0 which is equal to minus 3. Similarly T3 is equal to T2 plus D. Minus 3 plus 0 is equal to minus 3. Also T4 is equal to T3 plus D. Minus 3 plus 0 is equal to minus 3. So answer is minus 3, minus 3, minus 3, minus 3 and so on is the required arithmetic progression. Such arithmetic progression is called constant arithmetic progression, constant sequence. Now let us study the third example. A is equal to minus 7, D is equal to 1 half. Solution, see D is equal to 1 half, that is D is equal to 0.5. So first term A is equal to T1 is equal to minus 7. Now finding the second term T2 is equal to T1 plus D by adding common difference D in the previous term T1. So minus 7 plus 0.5, half means 0.5. So minus 7 plus 0.5 is equal to minus 6.5. Similarly T3 is equal to T2 plus D. Adding common difference in the previous term T2. So minus 6.5 plus 0.5 which is equal to minus 6. T4 is equal to T3 plus D which is equal to minus 6 plus 0.5 which is equal to minus 5.5. So answer is minus 7, minus 6.5, minus 5.5 is the required arithmetic progression. Take the fourth one more example. A is equal to minus 1.25, D is equal to 3. Solution, here first term A is equal to T1 which is equal to minus 1.25 and D is equal to common difference 3. So finding the second term T2 by adding common difference in the previous term. So T1 plus D minus 1.25 plus 3, so which is equal to minus 1.75. T3 is equal to T2 plus D, again adding common difference D in the previous term. So 1.75 plus 3 which is equal to 4.75. Similarly T4 is equal to T3 plus D, 4.75 which is T3 plus D3, so 7.75. So answer is minus 1.25, 1.75, 4.75, 7.75 and so on is the required arithmetic progression. So in this way we know the first term and common difference D, then we can obtain the whole required arithmetic progression. Now take the last question of practice set 3.1. Find the first term and common difference for each of the following arithmetic progressions. First arithmetic progression 5, 1, minus 3, minus 7. So solution here, first term a is equal to t1 is equal to 5, second term t2 is equal to 1, third term t3 is equal to minus 3, fourth term t4 is equal to minus 7, and so on. Now we have to find the common difference. Given sequence is an arithmetic progression, it means that difference between any two consecutive term, either difference between first two term or difference between next two term or difference between next two term, is always a constant. So d is equal to t2 minus t1, 1 minus 5 which is equal to minus 4. So common difference d is equal to minus 4. Also difference between t3 and t2, that is d is equal to t3 minus t2 is equal to minus 3, minus 1, minus 4, which is also minus 4. D is equal to t4 minus t3 which is equal to minus 7 minus 3 which is equal to minus 7 plus 3 which is equal to minus 4. So for finding the common difference d, take difference between any two consecutive term which is equal to common difference. So common difference d is equal to minus 4 and the first term a is equal to 5. So answer is the first term a is equal to 5 and common difference d is equal to minus 4. Next arithmetic progression 0.6, 0.9, 1.2, 1.5 and so on. Solution here a is equal to first term t1 is equal to 0.6, second term t2 is equal to 0.9, third term t3 is equal to 1.2, fourth term t4 is equal to 1.5. Now common difference d is equal to t2 minus t1, 0.9 minus 0.6 is equal to 0.3. This common difference may be obtained by taking common difference between t3 and t2. So d is equal to t3 minus t2 is equal to 1.2 minus 0.9 which is equal to 0.3. Similarly, common difference d may be obtained by taking common difference between t4 and t3. So 1.5 minus 1.2 is equal to 0.3. So answer is the first term a is equal to 0.6 and common difference d is equal to 0.3. Now third example, arithmetic progression is 127, 135, 143, 151 and so on. Solution here also first term a is equal to t1 is equal to 127, t2 is equal to 135, t3 is equal to 143, t4 is equal to 151. Now common difference d is equal to t2 minus t1, 135 minus 127 which is equal to 8. This common difference may be obtained by taking difference between t3 and t2. So t3 minus t2, 143 minus 135 which is equal to also 8. So again d is equal to t4 minus t3 is equal to 151 minus 143 which is equal to 8. So answer is the first term a is equal to 127 and d is equal to 8. So in this way, if we have to given an arithmetic progression, then we can obtain the first term a and the common difference d. विद्यार्थी मित्रांनो, आपणास या ठिकाणी सूचना करण्यात येते की कॉमन डिफरन्स डी हा अरिथमेटिक प्रोग्रेशनमध्ये एकदा काढणं अपेक्षित आहे, 2-2, 3-3 वेळा काढण्याची आवश्यकता नाही. तर अशा पद्धतीने या ठिकाणी ॲरिथमॅटिक प्रोग्रेशन दिली असेल तर आपल्याला फर्स्ट टर्म कॉमन डिफरन्स डी काढता येतो. उलट फर्स्ट टर्म ए कॉमन डिफरन्स डी जर दिलेले असेल तर आपण ॲरिथमॅटिक प्रोग्रेशन्स काढू शकतो किंवा ॲरिथमॅटिक प्रोग्रेशन्सची पुढच्या काही टर्म्स आपण या ठिकाणी काढू शकतो. अशा रीतीने या ठिकाणी हा प्रॅक्टिस सेट 3.1 होता. विद्यार्थी मित्रांनो, आपणास व्हिडिओ आवडला असेल तर या ठिकाणी आपण कमेंट करा, शेअर करा, चॅनलला सबस्क्राईब करा. धन्यवाद.